It's a moment that still haunts my dreams. I was in the middle of teaching a math lesson about quadratics, explaining how to find a vertex, when her hand raised into the air. And I call on her, and she says it. When am I ever going to use this in the real world? In recent surveys, business leaders have identified a need for workers with the ability to think creatively and develop innovative problem-solving methods. As a result, 21st century educators have been tasked with far more than simply getting students to understand content. They must also learn intangible skills such as resilience, collaboration, and adaptability. In math education, a particularly successful iteration of teaching these skills is called the 3-act task. 3-act tasks are a paradigm for an inquiry-based approach to lesson planning and problem-solving in the math classroom. Rather than textbook math problems divorced from real-world context, 3-act tasks require students to apply math skills to authentic situations they encounter in their daily lives by assessing a problem in set stages and using critical thinking and collaboration to develop methods for solving it. The paradigm, which was developed by a high school math teacher and now Chief Academic Officer for Desmos, Dan Meyer, derives its name from its 3-pronged method of inquiry. Each step in the inquiry process, which is referred to as an act, is designed to enhance student opportunities to engage with an authentic problem wholly and intuitively, learn collaboratively, communicate their thinking with precision, and develop metacognitive skills. Act 1 involves presenting an authentic question that engages students with a real but remarkable scenario that's designed to lower the barrier of entry to a problem. That is, make it so enticing the students can't help but be interested. They're first shown a video or photo that presents a real-world situation. For example, how many donuts do you think are in this box? The teacher first solicits student answers and reactions, allowing questions that are both practical, like how many rows are in the box, and sometimes just for fun, like, what does Dunkin' Donuts have to say about this? The time spent thinking together orients the class around shared values of collaboration and curiosity. Next, students write down their best gut-level answer, which the teacher promises to revisit at the end to find out who was closest, giving the estimate intrinsic value and creating expectations of an exciting outcome. Finally, at the end of Act 1, the teacher asks students to give one estimate they know is too low, such as 100 or 5 or 22.87, and one they know is too high, like 1,000,000 or 2,000 or infinity. Thus, the stage has been set for authentic inquiry. Act 2 is when students think about how to model solving the problem. The goal is for students to ask themselves, what information is important and how am I going to get it? The teacher begins by asking, what do you need from me? What information will be necessary? Students then start to think aloud and work collaboratively. When a fact-based question is asked, such as, how many rows of donuts are there? The teacher first solicits estimates or discussion before simply giving the answer, referring students back to the primary source to reinforce its importance in the learning process. As students answer these questions, they confront functional issues in the inquiry that refine their thinking, such as the language they choose to discuss the problem. Attending to the precision of language, especially around units used in the process of inquiry, is an important element in modeling real-world problem-solving processes. Answering these intuitive questions is also a great opportunity to engage all students in the classroom, regardless of ability level, and further develop a strong classroom community. The second act ends with the teacher filling in any missteps of inquiry, and then using the model the class developed to attempt to solve the problem presented. Act 3 is all about revealing and discussing the answer. First, the solution is presented to the students. The teacher then makes good on the Act 1 promise to find out who was the closest to the actual solution, which reinforces the value of student buy-in. And then the discussion begins. Was your estimate close? Why or why not? Were there surprises in the process of solving the problem? What would you do differently next time? Students use this time to examine their methods and validate their conclusions. Teachers can also use this discussion to formalize the methods used. Vocab is introduced or reinforced, misconceptions are corrected, and methods or models are given more structure and precision. Next, teachers can ask the students to name the activity. This is a great chance for students to think creatively about what they've just done and summarize it using a few words. Finally, students are asked to solve a sequel, a similar problem with the elements inverted. What if there were 200 donuts? How big of a box would be needed for those? While 3-act tasks have a lot to offer 21st century learners, there have been two major challenges in implementing them successfully. The first issue has been teacher training. Some teachers wrongly believe the problems are meant to be student-led and do not engage with the students in the learning process. Others are quick to reveal answers, again undermining the student progress in solving the problem. To help facilitate the inquiry process with less variability, Dan Meyer, the method's creator, has collaborated with the Desmos learning platform to develop tech-based lessons that further help teachers pace and deliver the lessons to maximize impact. The second challenge has been developing content. 3-act tasks are often labor-intensive, requiring the creation of videos and handouts that take valuable time outside of the classroom. Because Meyer was once a high school teacher, lessons were written almost exclusively for high school students. Over time, however, the use of lesson-sharing platforms, especially teaching blogs, has allowed teachers to create, share, and access content. And today, a wide range of lessons can be found for math students from kindergarten to calculus. Three-act tasks are a great way to engage math students while helping them develop crucial 21st century skills such as creativity, innovation, and problem solving. With lessons that require students to think deeply and without bounds about authentic problems, this method not only equips them with skills to make them more employable in the modern world, it also arms teachers with a great answer for when that sassy student asks, "Well, when will I ever use this?"